everyone, welcome back to Project for YouTube channel. This is me, Simran Anand. Welcome to the third, which is the final part of the series on customer churn prediction using machine learning. In our previous two videos, we have I've demonstrated you about how to build machine learning models, exploratory data analysis in order to predict customer churn, and explained you about how to select and evaluate machine learning models and the types of machine learning models which perform well under different scenarios. So in this video, I'm going to be leveraging PyCaret module, which is an AutoML module, and it's also a low code open source library. So it saves tons of our times and effort because we have seen in the previous videos that it takes a lot of time and knowledge. Domain knowledge is required in order to optimize the performance of machine learning models to actually gauge which machine learning model performs best and to evaluate. So it also even cleaning, of course, cleaning the data pre-processing also took a lot of time. So in order to automate all the steps we had seen in the machine learning workflow, it's always good to have an automation tool. So I'm introducing in this video, I'm going to introduce you to PyCaret, which is an AutoML module, which actually automates all the machine learning workflow steps we had seen and gives us a better picture with good results so that we could build models for customer churn prediction. So let's dive into this topic. The implementation is in Google Colab environment only. So in continuation to the previous video, wherein I explain about how to build machine learning models, selection of models, and so on. In this video, I'm going to talk about automation of those steps using PyCaret. So, as we have seen that AUC score, which was an evaluation metric, I'm explaining you that the evaluation metrics like accuracy, precision, recall, F1 score, and we have also came across AUC score. So our data is an imbalanced data. We had a churn data set which was highly imbalanced. So AUC score is a better metric to evaluate ML models when data is imbalanced, is what we had concluded from the previous videos. So it can be considered as a primary metric of evaluation. So we have observed that most of the ML models gave high AUC scores. So that is what is observed in this particular. Even in the previous collab file, which we have seen, that AUC score was pretty good, and even the precision was good. We got the accuracy of around 82 or 84% for the machine learning models. We had leveraged logistic regression, the ensemble methods like random forest, and also a decision tree classifier. So coming to actually going with an automation tool, say that we do not have the knowledge of domain knowledge as to which machine learning model to go out, and we cannot test and try out every machine learning model, or even we don't have the time to pre-process the data. So for such large data sets, when we want to save time and we need some kind of an automation, there is an open source low code library which is PyCaret. So give you an introduction. PyCaret is an open source less code machine learning Python library for automation of the entire machine learning workflow, and it is wrapped around some ML libraries such as sklearn, which we have seen in the previous videos. Also for any ML model, sklearn or scikit-learn is a really very crucial important machine learning library. Then we have XGBoost, extreme gradient boost, LightGBM, CatBoost, Spacey, Optuna, Ray, and many more. So PyCaret provides AutoML function in the regression module. We also have the classification module in PyCaret. So, PyCaret, which is AutoML module, has regression and classification. But for our use case, since we are dealing with, classification module and we have categorical data and not continuous data, the target variable, as you have seen, exited or not exited, or which is a churn variable, was, the classification. It assumes the classification task. So PyCaret, it provides important functions. And those important functions are save model function, load model, and AutoML functions. This is used in the classification module, whereas in the regression module, we just have the AutoML function. So save model function, we're talking just before delving into our use case of customer churn prediction as to how we will be leveraging AutoML in order to predict results and also compare the results of AutoML with our traditional results, model which we have built earlier. I would like to first explain you these three functions of PyCaret to just get to help you get acquainted with them. PyCaret first, it provides PyCaret.classification.save model function. Now, what does the save model function actually do? It saves the transformation pipeline and train model into the current working directory as a pickle file. So whenever you're saving any machine learning model, say, in general also, when before actually deploying any model to prediction, because whatever you are, even if you build machine learning model of customer churn prediction, ultimately you need to, for inference, send it to some production environment. The production environment can be any cloud service provider or any hosting platform. But in order to do that, you need to wrap up or encapsulate all the modules together. So for doing that, you can pickle or save the files. So saving the model over here, save function, it saves the model as a pickle file. So I have implemented the code, and on the left hand side, you will see saved lr model.pkl. .pkl is the extension for the pickle file, which got saved after having executed the code. So in order to first install PyCaret into your Google Colab environment, this is the line, and you see that whatever codes I'll be explaining, they are just one or two lines, not even more than that. We need to, it's just calling in the libraries, functions, suitable functions of PyCaret, and that does the job for you, saving lots of effort and lots of thinking, domain knowledge as to which evaluation metric to consider and what all. So when you install PyCaret, this is the code for installing PyCaret. All the requirements are satisfied. I have installed it into my Google Colab environment. Next step, I have just, for the demonstration purpose, in order to show you what is the different functions of PyCaret, I've taken a dummy data set before jumping into the customer churn data set. This is just for your understanding. I've taken the dummy data set, which is using from the PyCaret. By the way, PyCaret is a library which has its own set of data sets. So it has already pre-built or inbuilt data sets as well as inbuilt functions. So similar to Python, Python is built, having a lot of inbuilt functions. So similarly, PyCaret has inbuilt functions like get data of Iris. So Iris dataset is already, you have datasets pre-built like Boston dataset, for example, Iris dataset, and such datasets are already pre-built or inbuilt in PyCaret environment. So when you call in the PyCaret get data function, importing the classification module, you do that by writing from PyCaret.classification import star. This will import all the modules of classification. Setup is the function for setting up, you're passing in the parameters is data equal to iris and target as species, because you are going to actually predict species. But in our use case, it is predicting target variable, which is churn. You're actually checking whether the customer is churning or not. So just for the demonstration purpose, taking in species, applying a create model. Create model is again a function in PyCaret, which actually creates the model or sets up the classifier environment. So when you see LR, which is logistic regression, saving the model using save underscore model is the function. You save the model and the model gets saved in the PKL format. Over here, you can see it's a .pkl file, which you can also download from the, you can just click on download option from the Google Colab. So you see here, this is the result we got after executing. You see that this is the execution, and you see it has different it first shows us the overview of the data, and finally it also shows the description. So what all has actually been done by this PyCaret. You see we don't actually have to spend time on exploratory data analysis, because that work is already automated. Pre-processing is also be done because it says true. The value is true for pre-process. So we, actually just writing this code of PyCaret importing into the module actually saved a lot of time and effort, because it already pre-processed the data with better results. Target mapping has been done. That's very important, which I was talking about encoding. When I talked about in the previous videos about one hot encoding, label encoding, that already has been taken care of. We have target variable species. It's already identified. The value is multi-class in this case. Then it's also given the imputation type, which is simple. If there are any missing values, it has already imputed them or replaced them with something, which is imputation. Numerical imputation with the mode or the means of imputation is through mean. Categorical imputation is done by mode. Then we have CPU jobs. This is the overview of what all has been done in this PyCaret. And then finally, you will get the list or the models which have been, the cross validation, especially, which have been done, and the evaluation matrix. So this will give us an overview of the evaluation matrix, how our model has actually performed. So you see accuracy, AUC, recall, precision, F1 score, and so on. The metrics have already, these metrics have been considered for evaluating the model's performance, along with the mean and the standard deviation. That was all about it for the iris dataset using the save model function. Now coming to the load model function, what exactly it does in PyCaret is that PyCaret, it provides this load underscore model function from PyCaret classification library, and the load function, as the name says, it loads previously saved pipeline. So if you have already a saved pipeline, it loads the previously saved pipeline. So you see here, import load model, it's going to load the saved LR model. The saved LR model was a PKL form, or the already saved library, say a saved file, which was the iris on the iris data set implemented for using logistic regression classifier. That saved model is a pipeline which is going to be passed in as parameter to load underscore model. Then if you print out saved model, this is what is going to be displayed, which is the transformation pipeline and model successfully loaded. The model has been loaded after all the imputations, label encoding, and the categorical imputation has been implemented. So you see here, this has made our task very simple because we didn't actually have to import sklearn and other such libraries separately and independently, because PyCaret was, as I was giving the introduction, PyCaret already is wrapped around such important libraries for all this, which is sklearn, consists of all the decision trees, ensemble methods, and everything wrapped up, whichever is required for actually building a very effective machine learning model. By the way, for your information, along PyCaret, of course, it gives us good results, and it is an AutoML module which is recommended. It's also a low code library. Along with PyCaret, there are other modules as well. Of course, they are not much important, not that important, but I mean, not that prominent or popular, but other ones you could explore are Model Zoo and even Lazy Classifier. They're pretty recent, but they actually give us an overview and help us to compare the performance of different models. They compare models and load them. They have similar functions. But for the purpose of this video, to actually help you in understanding how to actually get started with automating the machine learning workflow, because you need not actually do it from scratch. There are automation tools available, and PyCaret being the most prominent of them, this is the sole purpose of why we are leveraging it here. So when you do that, now coming to the next function for classification, which is AutoML function. As the name says, AutoML is the most important function and the important task for PyCaret as well. So AutoML function returns the best model out of all the trained models based on the optimized parameter in the current session. Now, when I said, having said that, when I say it returns the best model, we have all the trained models which the model has already trained. It takes some time, epochs. After doing that, out of all the trained models, it gives us an overview whichever is the best performing model. Now, when you see this on doing, writing the code for tuning in, comparing the models, compare underscore model is the method, by the way. You see the comparison of the models in terms of the four evaluation metrics, which is accuracy, UC, recall, and so on. By the way, this above one is also about the different models. So you see that different models have been evaluated and their evaluation metrics are also printed. That was all about, overview of PyCaret, how it can actually save a lot of time for automating. Coming to the churn prediction topic, which is we are going to do it and test AutoML PyCaret for our data set. It will not take a lot of time. So now that you already understood the functions of PyCaret, what all they are used for, it makes it very easy for for you to understand each and every function which I'll be demonstrating. So you're loading in pandas and numpy as usual, because those are the since you are reading your CSV file, which is the data set in the CSV format as a data frame, you need the PD or the pandas library. So that I've imported that. This is the data set we are working on, and this is the same data set which I have been using for my first and the second videos. The churn data set basically of a bank. Now coming to the code of PyCaret. Now that you've installed PyCaret, set up the environment, model data equal to df.sample. This particular line will actually help us in sampling or splitting the data. Now 0.9 fraction is equal to 0.9 random state. You're setting some value for random state. Now it means 0.9 means that 10% is testing data and 90% is, because 0.9, so 90% is goes for training out of all the data set. So this is what you use df.sample. You see how we need not actually import train test split library also. Just by using df.sample and passing in the required parameters, we are actually calling in the PyCaret functions for train test split. Once this is done, df.drop, we're going to drop on the unseen data. This is the variable. We are going to drop model data.index. We're going to reset the index by passing the parameter drop equal to true, in place equal to true. In place equal to true means it's going to drop in place. So that is, it's like, it's not going to actually create a copy of the data frame and then remove or drop in the features, but rather it's going to drop in the features or columns in the same data set as well without creating a copy in the original data set. So that is what it means by in place equal to true. Then data for modeling is, to get an overview. This is again EDA, where we're just getting in the shape of the data, shape and size of the data. So you see here the 9,000 rows for training and 1,000 rows for testing. So it means that, as our data set was 10,000 rows, out of 10,000, we have done train test split, which is 90% goes for training. That is by 9,000 for training, and that is for modeling. And for testing or prediction, we have 1,000. Once this is done, coming to the most the best part of it, which is classification. This, actually you can see all the list of steps which are actually completed by the PyCaret by just writing this piece of code, which is PyCaret.classification import star. We're first loading in the classification module. Setup is the main function, which is used to set up, is passing in the model data, which is a churn data set we have. Target is equal to exited. Now this is important. Target can be the anything, any column you are specifying. But since in our data set we have seen that last column was the one which is a label, which was a target label, having 0 and 1. Since we're doing prediction on that, predicting whether the customer is churning or not, exited or not. So that is it becomes a target for our setup function. Session ID is 123. This is again a hyperparameter, a value which can be set. Description and value, you see the session ID, target, target type, pre-process, all the steps are actually automatically done by AutoML, which is PyCaret. Now comes the part which is compare models. Compare models, it compares the performance of each and every model and gives us the evaluation metric of each of them. Now you can see we need not even, say, empirically compare them one by one. Rather, it gives us a tabulated form of all the comparisons. So all the models are listed over here. Along with that, they are even their evaluation metrics, the performance values are also present over here, which makes it very easy for us to, in one glance we can actually compare which is higher. And you see the highlighted ones in the table are the highest ones. So from here you can see gradient boosting classifier performing the most best in the model, which gives AUC score. Now we said that AUC score, precision are the two most important metrics of evaluation for imbalanced data set. Now we can consider AUC score and precision. So in terms of precision, we see that the highest is 0.77, which is given by random forest. And even in the previous video, we were trying out random forest, which we have already guessed, because ensemble methods, we know that they work really well for, imbalanced data set by they actually help us in achieving a balance between bias and variance is what we know. So random forest gives the highest precision out of all these. So by the way, all these are the different classifiers which are tested and which have been built already by PyCaret library. You see gradient boosting classifier is giving the highest accuracy as well as the AUC score, which is area under the curve. It gives around 86%, which is pretty good for our imbalanced data set. Coming to the next model, which is light gradient boosting, and which gives us a highest F1 score. Of course, the F1 score is not that high in the other models, but light GBM, which is a gradient boosting classifier, gives as well. Gradient boosting classifier is based on the boosting technique, whereas random forest is based on the bagging technique. Then we see the random forest, extreme gradient boost, error boost, and so on. And logistic regression giving us not that but moderate kind of results. But you see here, naive based on SVM we have not implemented as well, because in general also we can say that I was saying you that naive based is has this kind of an assumption that the features are independent of each other. There is no relation between them, but that is not practically possible in our dataset. And our dataset is actually having relation even between the features. We have already explored in the first part of the video. So that's why naive Bayes did not perform that well, although it gave us a pretty good accuracy of 78%, a moderate kind of accuracy, but the other metrics are not good, which is evident, and it ranks among the last three. And even we see SVM, which is not giving us good accuracy or even an evaluation metric for our data set or our use case. So when we see here, we can say that, generalize, we can say that ensemble techniques and boosting classifiers actually give us better results. So we can go ahead with building those models and then wrap them, save them up as pickle files, and then create endpoints and use it for inference or for production environments. Now that you've understood gradient boosting classifier, gives this kind of technique. So when we see here, we have understood that gradient boosting classifier gives us the highest AUC score and accuracy. We go in with that. This is a summary of all the parameters, the values, hyperparameters of gradient boosting classifier. Since we are proceeding with GBC, which is abbreviated for gradient boosting classifier, we are passing in that as parameter to create underscore model method, which is actually creating an ML model for us. So writing this one single code is just like, writing commands to a computer, we can say. We're just giving commands like create model, setup model, compare model. Those kind of commands are given to this particular library. With the help of PyCaret, is actually helping us to save time and do lots of mundane work, we can say, because all pre-processing, data cleaning, feature engineering has already been taken care of. So don't you think this is actually a go-to library, I would say, especially for large data sets? So let's see how results we are getting. So we get create model GBC. We see these are the evaluation metrics. we get a mean and the standard deviation of the data as well, the data values. Finally, we are now that we have trained our model, built a classifier of gradient boosting classifier for customer churn prediction, the time comes to use the predict underscore model function to actually predict on the unseen data. The unseen data or the test data is the 1,000 rows, the holdout data set. Okay, the held out data set, but the 9,000 rows are used for training. After training on the 9,000 rows, on the remaining 1,000 rows, you are actually going to test or predict your data. So using predictive analytics, we are using predict model. Model GBC is a model you're going to pass into this function. You see that this is the score we are getting on the test data. So this is actually the performance. Accuracy is around 86%, not bad. AUC score has kind of increased to 87.5%, which is pretty good, indicative, or at least for our use case of an imbalanced data set, we can say that we can go with gradient boosting classifier, and because it's giving us pretty good metrics as compared to the other models. We see recall, precision, F1 score as these values. So now that we've understood that this is the machine learning concept, how we are building models for customer churn prediction, comes the time to finalize the models and predict the model on the final model. The final models, we are using the finalized model method of the PyCaret library, and finalizing, we are telling our model, building a model that we have finalized in a model is the GBC or the gradient boosting classifier, and go ahead with that. We are going to pass in that, and the data is unseen. So on the unseen data set, which is the test data set, we're going to pass in. This is the unseen predictions we get and the overview of the data set. Now, this is the overview of the data set we have. We have exactly the same data set we were working on. Surname, credit score, geography, and so on are already being tabulated over here. And the last column you see, this is the exceeded, which was the target label of ours. Prediction label is what it has been predicted correctly. Prediction score has also been present over here. This is all about how PyCaret has automated our workflow, ML workflow, and AUC plot. Now that we understood that AUC plot, AUC score or area under the curve is 87.5% around. So it's always better to visualize that data, since we have seen that data visualization is actually helpful, in actually better understanding or inferring before, making conclusions. So we can actually plot by using this method, which is again an inbuilt method in PyCaret AutoML, which is plot underscore model. So plot underscore model will actually, it's given, if you just hover over it, you will see the description of what each function is doing. So this plot method is, what exactly is doing, what hyperparameters it's to pass. Whenever you're stuck in anything, you can actually refer. So plot model, pass and final model. We have finalized the model as GBC, by the way, gradient boosting classifier, since that gave us the highest performance, highest metric of performance in AUC as well as in precision. We saw that random forest has given. By the way, you could also, instead of going ahead or proceeding with GBC, you could have also proceeded with random forest classifier and check for yourself the AUC curve. But since we have seen that the AUC of GBC is higher, there's gradient boosting classifier, we have proceeded with that. Plot is equal to AUC will actually give us the plot, AUC plot, and you see this is the curve. So this is a pretty good curve, we can say ROC curve for a gradient boosting classifier. On the y-axis of the AUC curve, remember that we have the true positive rate, and on the x-axis we have the false positive rate. You don't see any negative over here, because that AUC curve, when is we have an imbalanced data and we're only considering the positive classes. So to actually, it's similar to precision, because you've seen that precision also takes into consideration, and precision, recall, even F1 score, they actually take into consideration the positive classes and not the negative. They don't focus on the negative classes. The positive classes are going to be emphasized on. So that is what we are seeing, comparison. Basically a plot, a graph, or to know the relation between the variables as plotted by the true positive rate versus the false positive rate. So that is why we are getting, we are plotting this kind of graph, and we see that this graph is pretty good, we can say indicative. And we to know that is also printed over here in the legend, that ROC of class 0, which is customer not exceeded or not churn, is a 0.89. Even for customers who have churned, it's 0.89. So it says that 89% is the overall performance of the model. Micro average is 94%, which is 0.9, and AUC for micro average ROC curve, AUC value is 0.89. So this is again the result we can conclude from the data visualization, the AUC plot. That was all about how simple this entire, the inbuilt functions of our PyCaret module, which we have implemented, has actually automated the ML workflow completely. And that is, now that you've understood that which model to select, which to go about with, and also got a clear picture about customer churn prediction, now we can actually get with this results, we can confidently say that how likely the customers are going to churn, and the companies can actually focus on retaining their existing customers. I hope my entire series on customer churn prediction using machine learning has given you insights about machine learning, the different steps of data analysis, also about AutoML, PyCaret, and the various concepts of ML that you should be thorough of. So that was all about the topic. Do check out Project Pro website to know more, because it has blogs, tutorials, recipes, 24 by 7 customer support. And stay tuned on the Project Pro YouTube channel for interesting videos and ideas. Thank you very much. Have a good day.